Hello, this is Ms. DB, and in this lesson we're going to do the last section in Chapter 11, which is Section 7 on circles in the coordinate plane. We are going to write equations and graph circles in the coordinate planes and then use those to solve problems. Alright, so we've done lots and lots of work with circles this chapter. Now we're going to put them in a coordinate plane. So there will be an x and y axis. The center will be at HK. So the center is going to be at HK. And a point on the circle is XY. Basically, if you use the distance formula, you will figure out the equation of a circle. A formula for a circle. So if the center is at HK, the formula is x minus h, that's the x coordinate of the center, and then you square that, put parentheses around it, square it, plus y minus k squared equals r squared, that's the radius. The radius squared. It looks a lot like Pythagorean theorem, doesn't it? X squared plus b squared equals c squared. Very similar. If the center is at 0, 0, it becomes even a simpler equation. All right, so this is most of what you're going to do on your worksheet, is you're going to write equations of the circle. It might help you to draw a picture of it, or to get Sketchpad or Desmos.com open. You can put the center at 2, 2, and the radius is 4. So if this is 2, the radius has to be 4 more units away. 1, 2, here would be 2 more units away. So the radius is going to go all the way to here. And on this side, you have to have a radius of 4. So there's 2, there's 2. So your circle will be roughly like that, and the radius is 4. So the formula for a circle is, or the equation, is x minus h, y minus k, both of those are squared, equals r squared. Don't forget to square r. That's the biggest mistake I see students make. So x minus 2 squared plus y minus 2 squared equals 16. They're going to write the exact same thing I wrote. That's it. That's your equation of your circle. Now they can get a little bit trickier. This one doesn't tell you what the radius is. It tells you that it passes through this, and it has this for a center. So you need to find the radius before you can go any farther here. In order to find the radius, you can use the distance formula. If you know, let me sketch this, and it's going to be ugly, but let's sketch. The center is at 1, -8. So let's say this is at -8. And here's 1. Oh, sorry, 1 would be right here. 1, -8. And it passes through 6, 4, over 6, and up 4. So that's one of, if that's the center, and this, if this is the center here, and it passes through this point, which just got erased. Oh, that's not very good. It should be a little more rounded. So the radius is from here to here. So your radius is found with the distance formula. So we have one point at 1, -8, and we have another point at 6, 4. The length of this is the radius, and it is found with the distance formula. So there's the distance formula. You can look it up if you need to, and the distance formula will give you the length of the radius. So you take x1 minus x2 and you square it, and you take y1 minus y2 and you square that, and then you take the square root of the whole thing. So r is equal to 6, here's x1, minus 1, that's x2, and then you square that, so that's going to be 5 squared. And then you take y1 minus y2, so that would be 4 minus a -8, which is the same as 4 plus 8. And then we simplify as much as we can, and 25 plus 144 is 169, and then you take the square root of that, and in this case our r was a nice whole number of 13. Once you know what r is, you're ready to write the rest of the equation of the circle, which remember is r squared equals x minus 1 squared plus y minus a negative 8 squared. Remember, it's x minus h and y minus k. And here's your center is hk, and our center is 1, negative 8. So h is 1, k is negative 8. And then you simplify. You would not leave this like that. So you would simplify to x minus 1 squared plus y plus 8 squared, because minus and negative is the same as plus. And then square your radius to get 169. So do simplify your equation as much as you can, but you can't do anything else after this. We want the x and a y in it. It's just like when you write the equation of a line, right? You can replace the m and you can replace the b, but you don't replace the x and the y. You might get y equals 1/2 x, 1/2 x plus 3 or something. The x and the y stay in them, just like the x and the y will stay in the equation of a circle. This one, they give you the radius, so that's the easier type of problem. All you do is substitute in 0 for h, and k is negative 3, and simplify. Don't leave that y minus a negative 3. Change that to y plus 3. Also, there's no sense in leaving x minus 0. That's just going to be x squared. So now we have x squared plus y plus 3 squared equals r squared, which is 64. And this is the more complicated one. In order to find the radius, you need to know the distance between the center and a point on the circle. So you would, and again, you can sketch that if you want. The center is at 2, negative 1, and it's going to pass through the point 2, 3. This one, the radius is easier to find because it's just going to be a vertical line. So when you take the distance between them, you'll find that the horizontal distance is 0. So it's really just 3 minus a negative 1, which is 4, because 3 plus 1. And then square that, you get 16. And the square root of 16 is 4. But again, if you graph that, you would have got that a little bit quicker. Now that you know what the radius is, you can plug in your values for h, k, and r into your equation of a circle. Simplify, so you have x minus 2 squared plus y plus 1 squared equals 16. You will get this wrong if you do not have parentheses around your x minus h part and your y plus k part. It's very important that you do have parentheses. Notice that we are not going to take x minus 2 times x minus 2 and FOIL it and all that. We're just going to leave it like this. This is our formula for a circle. You can also take the equation of a circle and you can answer questions about it. You can say, all right, if this is your equation of a circle, what is the center? What is the radius? So if you write down the equation of a circle, and we're not going to worry about graphing it. If you write down the equation of a circle, it is x minus h squared plus y minus k squared equals r squared. Now we have x squared and we have y squared equals 16. How do you turn 16 into something squared? You write 4 squared. So I already know the radius is 4. Radius is going to be 4. What about h and k? There's no numbers in the parentheses with there. There's not even a parentheses. That must mean that the center must be at 0, 0. So the center of this circle is at 0, 0, and the radius is equal to 4. So then to graph this, and you won't have to do much of the graphing, you would put the center at 0, 0, and then you would go over 1, 2, 3, 4 to make the radius, and then go down 4 to make another radius, and then go over to the left 4, and then go up 4. And you could do this table of values they're talking about to kind of help you, because otherwise people tend to make kind of a diamond shape. but if you can, you want to connect your circle so that it actually looks like a circle, and it helps if you make your radius points first. All right, let's look at this one. What you're going to have to do on your worksheet is you're going to have to say, what is the center? What is the radius? So a little bit different than the way the book expresses this, because it's quite hard for us to, if you're using Word, to make a circle. You can draw one using the Word tools, but it's a little bit easier to tell me what is the center, what is the radius. So remember how the formula goes. It's x minus h squared plus y minus k squared equals r squared. If you are asked on a quiz or a test, what is the radius, if this is the equation of the circle, and you say 9, it'll be wrong. The radius is 3, because the formula is equals r squared, and 3 squared equals 9. The center is, this would be our h, because that's directly, it's minus and minus. But this, you'd have to write y minus a negative 4 to turn it into a plus 4 in the equation. So the center would be at 3, negative 4. And then if we were going to graph that, I would put the center at 3, negative 4. 1, 2, 3, 4. And then I would, the radius is 3, so I would go from the center, I would go up 3, and I would go down 3, and I would go to the right 3, and I would go to the left 3, and then I would curve this, or I would use the Word tool and grab a circle tool and try to center it at the center. Now they're going to show that pretty much the same way we did, except their circle is going to be nicer looking than mine. Oh, theirs is way prettier than mine. Nice, perfect circle. Okay, what is the center? What is the radius? That's what you're going to be asked on your worksheet. So your radius is 3. We don't use negative 3 for a radius. And then you can use a table, but you're not going to have to show that. And you're going to say, what is the center? The center, if it's just x squared and y squared, the center is 0, 0. And the radius is 3. There's their circle. One more. The center is going to be 3, negative 2. You can go up here and say, take the opposite, take the opposite. That's the center. And the radius, of course, is 2, because the square root of 4 is 2. So when you graph this, first put the center in, 3, negative 2, and then make your radius go up 2, down 2, over 2, over 2. And once you have those 4 points, you can use the, if you're using Word, use the circle tool and attempt to create your circle in the right spot. It's a little tricky, or you could connect this. Most of what you're going to be doing on the worksheet is naming the center and the radius, and maybe matching the graph. All right, so there's an application problem. It's kind of lengthy. Let's see what it says. We have an amateur radio operator wants to build a radio antenna near his home without using his house as a bracing point, so he doesn't want to attach it to his house. He uses 3 poles to brace the antenna instead. The poles are to be inserted in the ground at 3 points equidistant from the antenna, so it's like a tripod. And that's where he's going to put his poles at 4, 4, negative 3, negative 1, and 2, negative 8. So if you have a tripod, those are going to form 3 points on the circle equidistant away from the center. Okay, so they're all radii. They're from the center, they're all creating radii. And the question is, what are the coordinates of the base of the antenna? What is the center of that circle is what it's really asking. So we are going to plot those 3 points on a nice coordinate system, connect them Now I connected them to a center that I don't know exactly the location of. So let me change this to a pen. Let me connect these points. Oh, I have my pen upside down, that's why. And that would make a nice triangle. And then we can find, let's see if I show that on the next page. The perpendicular bisectors, a point that is equidistant from 3 points by constructing the perpendicular bisectors of 2 of the sides. Now we did this way back when we talked about triangles. Okay, there's the circle. Okay, so we have the triangle, the 3 points of the triangle. That's what you have on there. And then you are going to construct the perpendicular bisectors of any 2 of the sides. If you have 2 sides that are either a horizontal or a vertical line, that will be the easiest. But if you don't, remember that to make the perpendicular bisector, you have to find the midpoint of your segment, and you also have to find the slope and then flip the slope upside down. Now they're skipping some of these steps. You will have one problem on your worksheet, but it'll explain each step to do so that you can remember. Now the place where the midpoints, or where the perpendicular bisectors come together, is going to be the center of the circle. The place where your perpendicular bisectors meet. And that will be where that doesn't look like the point 3, -2. 1, 2, 3, -2 would be right here. Oh, is that the 4th point? Is that what they're saying? Oh, these are every 2 units. Sorry, didn't catch that. So this is 2, this is 4. So this is 3, -2, the center of the circle. So 3, -2 is the center of the circle where they would place that antenna. So that's a fairly kind of complicated looking problem, and we probably only will do one of those, and the steps will be written out for you to follow. Most of the worksheet is going to be writing the equation of the circle, or looking at the equation of a circle and saying what is the center, what is the radius of that. So good luck. Let me know if you have any questions, and thank you very much.